So we now have our basic understanding of what an ion is and how ions are formed by either gaining or losing electrons. But the end-all conversation has to be, well, why are they going to form these chemical bonds? Remember, these chemical bonds are going to form because we want our atoms to become stable. If they become stable, that means they're going to have an electric charge that's either positive or negative. We know that opposites attract, so one of our positive atoms is going to be attracted to one of our negative anions. So we'll have a cation that is going to want to bond with our anion. One of our metals is going to want to bond with one of our nonmetals, because overall, all of our electrons have to be transferred. So in order for those to be transferred, one again is going to lose electrons and one's going to gain electrons. Hopefully with our activity on Friday, you started to see and predict how many atoms you're going to need of our anions and cations to form those chemical bonds. All right, so you guys have two options again. You can pick whichever one you would like to do. If you're going to do the gizmo, that's pretty straightforward. It'll walk you through step by step exactly what you are doing. But if you chose the ionic bonding basics, that is going to be including a lot of our Lewis dot diagrams. So for example, potassium and fluorine, we want to draw our Lewis dot diagrams for those first. Remember, as you add those electrons, you're going to go around. And you're going to do it this way because it's going to be a little obvious that right here fluorine is missing one of our electrons. So because of that, potassium has 1. If it gets rid of that 1, it can transfer that to fluorine. So the very first thing you have to do is draw your symbols for each of our Lewis dots for potassium and fluorine. And then we want to show that arrow transferring of the electrons. Next, we need to draw our K is now bonded to F. When you see that bond there, that bond represents 2 electrons. So this here in the middle, these two are a bonded pair. So that is representative of that bond right there. So we don't need to draw those electrons on there, but we do need to fill in the rest of our elements, or rest of our electrons. Let me go ahead and switch back. So we have 1, 2, 3, 4, 5, 6 that are still going to go on the outside of fluorine. Okay. I'm also going to make sure that some of my charges is 0. Well, potassium K is a +1, fluorine is a -1. Does that cancel out? Yep. So I know my final step then is KF is my final chemical formula. Okay. I'll even help you with number 2 as well. Magnesium is going to be a +2, iodine is going to be a -1. So if I look at a +2 and a -1, is that going to cancel? No. So since it's not going to cancel, I'm going to need to add another ion of, hopefully you know it's iodine. So when I go ahead and I write Mg, I have my 2 valence electrons. I have my iodine, which is in group 17. And you're going to notice that there is 1 that is missing. So that iodine is only going to form 1 bond. So I'm going to go ahead and take both these electrons, transfer 1 there, and transfer 1 there. So when I go ahead and fill in then my next step, I have magnesium that is going to be bonded to 1 iodine and bonded to a second iodine. I'm going to add in my electrons that are not also bonded. And then I'm going to double check my charges. I have Mg2+, I have iodine 1- and iodine 1-. Hey, guess what? Those cancel. So my final chemical formula will just be MgI2. Okay? So please go through as you're looking at this, make sure those charges are canceling out, because overall the ionic compounds do need to be neutral. All right, good luck. Let me know if you have any questions. So we can begin predicting our bond type specifically by what elements are involved in our compound. So if we see a compound that includes a group 1, 2, or 13 element, those would be our cations. and those also are called metals. Remember, our metals are to the left. If they end up bonding with somebody in group 15, 16, or 17, those are our anions, which make up our nonmetals. We know that bond's going to form because there's going to be that transferring of electrons. So our positive is going to bond with our negative, and that is going to form our ionic compound. Remember, the end-all goal, again, is to become stable. So they're going to form those chemical bonds so that they can become more stable like our noble gases. Ultimately, this is going to benefit both atoms because one wants to give up electrons and the other wants to lose electrons. So both end up being happy or stable. Because they are going to be transferring electrons, we form this ionic bond, and that bond is pretty strong. So when we look at table salt exists as NaCl, where one electron has been transferred from sodium to chlorine. Sodium is that +1 charge, chlorine being the -1. The overall atom, though, the overall compound, is going to be neutral, though, because we have to account for all those electrons. So again, in order to become stable, they have to completely fill their highest energy level with electrons. So for magnesium, with an electron configuration of 2, 8, 2, remember we talked last week that 2, I can either lose the 2, and then look, I'm completely full, or I could have added 6 electrons to become stable. Well, always pick the lowest number, which one's easiest to do. So when it loses 2, remember, it's opposite of what we think, losing negative charge gives it a positive value. So again, it is all dependent upon the valence electrons, which hopefully you have marked on your periodic table, as well as being able to identify, will they lose or gain so many electrons. The goal again is to fill that outer shell to reach that value of 8. That is our octet rule. So if I look at fluorine in my outermost shell, do you see how it is currently missing 1 electron right there? Because it is missing 1, it wants to gain 1 electron, and then that will make it completely full. Well, if it now has 9 protons and 10 electrons, you might notice 10 is similar to our neon. It's going to end up having an overall 9 charge. So sometimes, though, it's easier to lose electrons. Again, depending upon how many valence electrons it has, it can actually drop down to the next lower energy level and become full. So if I look at sodium in my outermost energy level, which is the 3rd energy level, there's only 1 valence electron. Well, if I completely get rid of that 1, now I'm not even using the 3rd energy level. And look, my 2nd energy level is now full. So sodium is going to lose 1 electron, which is going to give it a +1 charge. So either they're going to gain electrons or they are going to lose electrons. Okay, the goal is to have that full outer shell and be similar to our noble gases that are already stable.